This other one says that we are to find that the sector of the circle is given, the radius is 6. The same thing. In fact, without wasting time, just sketch it. I always want us to sketch so that you have a mental picture of what you are talking about. The sketch here. Since it is 300, let us further reduce it. Then the radius. degree. When folded, you have the radius, which is 6 here for radius, become the slant height. Becomes the slant height. So if that becomes the slant height, which is 6 cm, what is the radius now for this cone? That's what we are saying. So let's move on. You know this already. Quickly follow. Radius is equals to theta all over 360 times slant height, which you know, okay, where theta in this case is 300 degrees, and then slant height in this case is 6 cm. Slot it, put it inside the formula. So radius this time is going to be 300 all over 360, look up, times slant height, which is 6 cm. To cut the long story short, by the time you work on this and that, you are left with radius is equals to 30 all over 36. So what does that mean? What does that mean? Times 6 cm all over 1. Do you need to waste time there? Why not we just 6 cancel 7 1, 6 into 36 6 times. So let's clear the air. So you are now having 30 all over 6. So radius is equal to 30 all over 6. So by the time you do that way, as you know already, radius eventually becomes what? Yes, radius will now become what? 5 centimeters. That is the radius for that one. We quickly move to the last one. In this last one, you don't have to also panic. There's something I see in the last one. It's just like what we saw in the other one. A quarter circle of radius. So let's quickly move. If a circle is like this, you can recall what you were taught in chess 1. If a circle is like, if we divide it into 4, that is what we mean by quarter. So this side is 1 over 4, that is quarter. This side is 1 over 4, that's quarter. This one is 1 over 4, that's quarter. I'm only doing this to remind you. So if it eventually becomes this way, you have the circle like this. That is that. And then the radius of the circle here is given to me 8 cm. What is wrong? 8 cm. So in this case, angle at the right angle, you were taught it is 90. Let us not delay here. Here is 90, so theta will be 90 degrees. I have to rush you up in that case. So if you fold this one to have a cone, the cone will be like this. My student, you know it already. The cone will be like this. The angle is there. So remember, when folded, the radius of the sector or the semicircle now becomes the slant height of the cone. So slant height here is 8 cm. So we are looking for the radius. Let's rush up and bring out this radius immediately. Where are you? Radius, come out. Theta all over 360 times slant height, which is 8 cm. I'm trying not to delay, but let us follow the normal procedure. Times slant height. Let me not rush. Times slant height. So radius in this case, the theta there is 90 degrees. All over 360 degree times 8 cm all over 1. I have to speed up because I know you know the answer. By the time you reduce this to its lowest term, you have radius is equals to 9 over 36 times 8 all over 1. 9 over 36, you know, 9 over 36 radius now is going to be, let's go this way, it's going to be 1 over 4. Do we need to even go that far? Let us quickly cancel it here. 9 cancel itself 1, 9 here, 4. So you are left with 8 over 4. 4 cancel itself 1, 4 into 8 is what? 2 cm. We have finally found the radius to be 2 cm. That's interesting. That is just that. Don't you see? I told you this thing is simple. You don't need to be afraid of it. You have arrived at the radius there. So that is that. I'll still give you a break. You know, now I like giving you break so that you can refresh and come back for another example. That will be the last for this particular segment. Look at it there. They are the same thing. That's the same thing that you know. Take a break for just 2 minutes. Take a break, 2-minute break, and come back. We'll see you later. Welcome back from that short break. We are going to continue with example 4, which will also help you. We have to take time and do this so that you have a clear understanding. Another example. In this example, we are going to look at total surface area of a solid cone, TSA. I will be using TSA so that I will be able to, work faster. So in this case, we go straight to the solution, and then after reading the question, we go straight to the solution. Calculate the total surface area of a solid cone of A base radius 6 cm, slant height 10 cm, B base radius 8 cm, vertical height 6 cm, C vertical height 12 cm, base radius 5 cm. D, we look at that of the slant height 25 cm, when the vertical height is 24 cm. Let's quickly do that. This one is going straight to the point. Simple addition is there, simple multiplication is there for you. Now solution. Look at the total surface area. The formula is here, and then look at the cone here. The base radius of this cone is 6 cm. Slant height is this. Then what is the total surface area? So TSA here is equals to this one. I'm not going to do this. I'm not going to repeat it. But in this question, we say where you have to use pi. I forgot to mention that. Use the value 3.14 for pi. So in the question now we say where pi is equals to 3.14, radius is equals to 6, slant height is 10. So let us quickly put this in the formula. Pi is 3.14 times radius. Look up there, radius is 6 cm times slant height. Slant height is 10 plus radius again 3.14 times, this time say radius square, which is 6 times 6. 6 times 6. When you take time and multiply that, which I want to believe you should know how to multiply it. If you multiply it out, you will have TSA in this case is going to be this side 188.4 plus multiply this side also, you have again 113.04. That was why I said this one you need to take time and do your calculation and then check yourself. So we now say that the TSA in this case, the total surface area in this case, is when you add this to this thoroughly, you will have 301.44. You don't waste time there. That is as simple as ABC. So we move on to B. Okay, let's check B. I will not write the question, just look at the question here. The B aspect of it. Solution for B. For B. It's the same thing. But let's catch the code because there's something I noticed in B. Look up here. Base radius is given. Vertical height is given. Oh, no slant height. So we have to look for slant height. You see there? I taught you how to find slant height using Pythagoras. So, slant height now. Find slant height first. So in finding the slant height, we look at it from this point in a very quick movement. Find slant height. Find slant height first. So by Pythagoras, we are going to find slant height by Pythagoras, which you were taught already. So look at the cone here. Look at the cone there. And in this case, you are given from the question, the base radius is 8 cm. Look at it, the base radius is 8 cm. So if the base radius is given to be 8 cm, and then the vertical height is 6. Base radius 8, vertical height 6, which is here. So in this cone we can see radius of this cone is 8 cm. Vertical height is 6 cm. So let's find by particulars. Without wasting time here, let's quickly rush up that. Slant height is what we are looking for. This is it. Look up. We are looking for slant height, this side. So we can now say slant height raised to power 2 by Pythagoras square it is equals to 8 times 8 plus 6 times 6. We have to speed up because you know this already. 64 plus 6 times 6 is 36. So slant height is equals to 100. So allow the slant height, the L, to stand by itself. Use these two to build a square root sign for 100. So you are looking for square root of 100, which eventually will give you slant height to be 10. That is that. So you now have slant height already. Now that you have slant height, you know that. But we'll stop here. When I'll still give you a break. You know I like giving short breaks so that you can take down. Slant height is 10 cm. We'll continue after 2 minute break. You come back, we find the other aspect of